Welcome friends, welcome to the demonstration video of my newly created Python package pyMarketLab. In this video we will discuss how we can run a machine learning project on pyMarketLab. So we will start with data editing and data cleaning part, and then end this video by developing a machine learning model. So we will consider a housing data. So we will develop a regression model to predict the house price. So let us start our video, but before starting, let me introduce some features of this data editing part that my software has. So in this module you can do various you can apply various algorithms to deal with data cleaning part, such as missing data values or removing the outlier. So there are various strategies that we can apply to remove the missing value or to handle the missing value. So various strategies such as median, mean, or forward field, backward field, or using nearest neighbor methods. So you can apply all these strategies to handle the missing value, or you can simply remove the missing value. So it depends upon your knowledge, your domain expertise, and understanding of understanding on the data that you are dealing with. So depends upon the data you apply the strategies. So let us start the discussion with loading the my library. So you can load the pyMarketLab data pre-processing pipeline. So there are two versions of data pre-processing. One is the main version, in which you can open a window to load the file, or you can have the pipeline version, so that you can create a pipeline of various machine learning or data science projects. So here we are using the pipeline version. So you need to load a data CSV file in a data frame, and then you need to supply the data frame to the library. So here, if you run this dashboard will appear. So let us load the data first. So we have loaded the data. Now we will see whether is there any date column present in the data or not. So we can check directly. So you just click this the output, you just click handling data column button, and you will get whether the date time column is present or not. If there is no date time column, then nothing will happen. If there are some date time column present in your data set, then that will be transformed from string to date time format. So you just need to click this button. Now let us see how many nan values are present in the data set. So you just click, the report will be in before you. So here you can see that there are 207 nan values present in the total bedroom column. Now how to handle this nan value? Either you can remove the rows corresponding to this nan value, or you can apply some data imputation strategies like median, mean strategies. So it depends upon what kind of data set you are dealing with, and your knowledge about your data. You can apply various strategies. So I am not going to discuss the theoretical part or the basic concept of this thing. I am just demonstrating you how you can apply this strategy. So here, when you click handle missing value button, all the columns will be appeared, all the numerical and the categorical columns. So depending upon the kind of columns, you can handle or apply the strategy. So here suppose total bedroom has nan values. So suppose you want to apply median strategy, you can select the median strategy here, and simply you just click this button for numerical column. All the value will be replaced with the median If you apply some certain other kind of strategy, you can, there are many options are available, so you can use those options. So let us apply this median strategy to total bedroom. So now as you can see that median value, the NaN value has been replaced. You can check again. Now you see that there is no NaN value present in your data set, so you can move further. So let us now handle the outlier, how we can handle the outliers in the data set. So when you click this button, handles outlier, a histogram and some statistical report will be presented. So here these are the quartile range, Q1 median and Q3 quartile. Also you will be given outlier range also. So here you can select the column and see these statistics. For example, suppose housing median age, you can adjust the bin size here of this histogram according to your data. So here you can see, you can adjust the bin size to get a better picture of your histogram. Here a range is given. Either you can use this range or you can apply your domain knowledge to remove the outlier. So here you can set the range of the outlier, or you can type here also and apply the range. So in this way your outlier will be removed. Now once you have removed the outlier by selecting columns one by one, you can remove all the outliers. Then you click this button to drop duplicate rows. So you want to drop duplicate rows, so by clicking this button, duplicate rows will be dropped. Now you will save the data set. So let us save the data set in a CSV file, housing.p.pr, say any name you can give of your choice, and then save you. So your process data has been saved. Now we will do exploratory data analysis and identify certain pattern that we can explore in the exploratory data analysis. So in last step, in previous step, we just clean the data. We handle the missing value with various strategies, and we also remove the outlier with the help of histogram chart and quartile ranges, and we also converted the date time column into a proper date time data type, and also we dropped the duplicate values. So these were all the data cleaning part. Now we will explore the data and how we will explore the hidden pattern in the data with the help of various charts available on pyMarketLab. So you can create various charts and see the pattern in the data. So let us start our analysis. So here you need to run only two commands. One is you need to import the library, the EDA library. Other is to run this command ed.execute EDA. So here you need to import the library and name is ed. So you need to run this command. So let us load. We process the data and saved in house.pr CSV file. So let us load this file. So when you load this file, you will get these columns. So let us do the exploratory data analysis. There are many charts options available here. So you can explore these charts and see the hidden pattern in the data. So we'll start, since the latitude and longitude columns are present. So let us start with the geoplots. So we can do geoplots here. So you just need to assign the latitude and longitude value and the value that you want to see or observe with respect to latitude and longitude. So let us plot this value. So since the data points are very large, so it might take time. So it depends upon the size of your data, how much data size you have, your data set have. So let us plot this. So since it has plotted, so you can see the price house value distribution with respect to the location. So you can see this shore area, the house price is very high, whereas when you move further away from the shore area, the house price gets reduced. So these are the median house values, it gets reduced. So there is a clear cut relationship between your location and the house value. These are the scale, means minimum value you are plotting in a scale of minimum to maximum. So 0 means minimum, 100% means maximum value. So 80 to 20% means higher value that falls between 80 to 20% of that scale will be shown in red color, and accordingly the color code is assigned. So you can see these are the high median value houses, whereas when you move further you have the lesser values. So these are the position of the houses that you can see this. So these are the houses, house locations. So you can observe the house location. These are the houses near the ocean or the Bay Area. You can see that just nearer the shore region, or these are the Bay Area. So Bay Area you can see the price, or some houses are located on the island. So there are some island also. So now you can do some more analysis. So let us create some more chart like radar chart. So let us take the median value of the, and let us take the categorical column and plot the chart. So you have these charts. So here you need to select the value also. So this chart has been created. So here you can see that the island area, the median value of the houses is very high, whereas it is lowest for the inland area, and the house near the ocean is also high price, near the ocean high, near the Bay Area, but maximum in the island area. Now let us create a unstacked bar chart. So you can see the population and the household distribution. So let us see the median population. Here the population and the household. So in the ocean area you can see the ratio. Similarly you can create stacked bar chart also. So you can see the ratio and compare. Similarly if you want to see the median income and the median income of the houses, so you can create a radar chart or a bar chart. You just create a bar chart, sorry, you create a stacked bar chart. So you can create these charts. Also suppose you want to know the income distribution based on the area. So let us create a donut chart. Select the median income, then you can create a donut chart like this. Also suppose you want to know create a scatter chart. Let us create a scatter chart. Let us create a scatter chart like this. Just you can adjust the dot site here. You can create a scatter chart. You can adjust the dot site also. So these are your various charts. With the help of these charts you can explore the hidden pattern in the data. Let us create a bubble chart. So let's create with the house income. So a bubble chart has been created. You can adjust the size of this bubbles. You can see the income distribution in the area. So generally people who has higher income own higher value houses, whereas people who has low income, their houses are also low values. Generally people buy houses according to their pocket. So it depends upon your knowledge or your domain expertise how you will explore the pattern. Now in the next step we will transform the data. We will do various transformation, like we will convert this categorical column into numerical column for machine learning purpose. And we can also do binning, like we can bin this age value into low, medium, high value. In this way we can do transformation. We will scale the data. We will do feature engineering. We will select certain features. We can also do principal component analysis to reduce the dimension of this data. So let us move further to the next step. Now move to the feature engineering part. We have already explored the data. Now we will do feature engineering. So in this part we will transform various data type into other kind of data, and also we can do dimensionality reduction. We can select features based on feature importance. We can create feature importance chart, and based on which we can do feature importance. We will also scale up the data and we will save the data. So let us load the data. So we have processed the data housing pr.csv file. So we will just need to read this file and in a data frame format and supply this data frame format to this fe.ex execute feature engineering. So you need to import this library, execute feature engineering pipeline. So from pyMarketLab you need to import feature engineering pipeline, and then you can execute this command. So only two command you need to, means you need to import the library, and these two command you need to do. So let us load the data. Once you have loaded the data, next step is to do the feature transformation. So you have latitude, longitude, and you have some categorical column also. So you need to transform this column. So let us do the feature engine. So here you can do binning. So what is binning? So you can select any column and do binning. Then let us here I don't think binning is required, but you can do binning, like you can convert numerical column into high, medium, low, or some categorical column by binning. So now let us do we need to do the one hotkey encoding. So let us do one hotkey encoding. So only one categorical column is there, so you can do one hotkey encoding. So now your data has been encoded. So here your new columns has been created. So new columns has been created. Now you can save this. So this has been saved. Now you can check once again, there is no categorical column. So let us do data scaling part. So we can scale all the data. So let us scale all the data, including the target column, because that you want to predict. So let us scale. There are various scaling techniques are there: min max scaler, maximum absolute scaler, standard scaler, or robust scaler. So you can apply anything. So let us do standard scaler and execute scaling. So your data has been scaled now. All the data has been scaled. Just save the file. So depending upon the nature of your data type, nature of the column, you can select individual column and do scaling for different data column. You can apply different scaling method, or you can select all the column like this and apply as a whole. So it depends upon your data set. So according to your data set, according to the data column, you need to select the method. You can do dimensionality reduction also. So you can do PCA also if you want to do. So let us do PCA. So select all the column that you want to reduce. So select the feature column, but don't select the target column here, because you want to reduce the size dimension of the feature, not target. So here you need to select the target. You can execute PCA. Let us select the number of PCA, number of principal components. Execute this, you will get this result. So here you can see the PCA. Here you can see the eigenvalue also. So where the elbow point, you can select the elbow point and the number of optimum number of. Here you can see the eigenvalue, the variance explained. So up to this, I think 9 features is okay. So either you can transform or you can leave this also if you don't want. So if you don't want to save, then don't save, and if you continue with dimensionality reduction, apply this, save this transformation. Now let us do some feature selection with some feature selection method. So here you can select the feature column. So let us select the feature column. Don't select the target column here, only you need to select the feature column. And you have the target column. There are various methods through which you can determine the importance of features, like univariate, recursive feature elimination, and tree based. So let us apply univariate, and since we are going to do regression algorithm, not classification, so you just apply and display the feature importance. So here your feature importance has been displayed. So you can see that median income has the highest value, and proximity to ocean. So since this earlier it was a categorical column, so now it has been converted to numerical. You can see the importance of feature. So proximity, also total rooms is also a very important feature. So accordingly you can get the feature importance value. So you can select the features based on this. So here you can select the features. So let us select up to this feature, population, and you can drop, or you can continue with all the features. So you just select here. Since I have selected all the feature, you can remove feature. Once you click this button, your selected feature only will appear along with the target column. So let us save. Let us select all the features. Now save the process data. So we will save the process data. So let us name this housing processed data .csv. So our data has been saved. Now our data set is ready for machine learning purpose, because we have already transformed the data to a machine learning. It is ready for machine learning. Now after pre-processing the data and after feature engineering, our data set is ready for machine learning purpose. So now we will do the machine learning part. So here we will first split the data into training and testing sets, and then we will apply certain algorithm to do the machine learning task. So since here we are going to do the regression analysis, so we will build a regression model for predicting the price of the houses, median price of the houses. So you need to import one library, machine learning library from pyMarketLab, and run this command, ml.execute machine learning command. This upload button will appear. You need to click on this button and import the process data file that we have already done. So now these are our process data file. So that we have how we processed, we will import this file. Now let us load the data. So we need to select the feature column and the target column here. So these are the feature column that you need to select. So select all the feature column, or it upon your choice, or feature engineering part that we have already covered. You need to select this feature part, and then you need to select the target part and prepare training data set. So here our training data set has been prepared. So here we have all the feature column, and these are all the target values. Now we need to split the data set into training and testing set. So we need to split. Let us take 30% ratio, split the data set. So we have now training data set and testing data set. Now we can do machine learning part. So let us click this button, machine learning. Let us since we are interested in regression, so let us do regression. Select a model. Let us select a random forest model, and say here this is hyperparameter tuning. So either you can go with hyperparameter tuning, or you can run the default model. So if you have time, then I recommend you to go with hyperparameter tuning. Otherwise you can do without hyperparameter tuning, but hyperparameter tuning normally takes more time to execute. So let us execute it without hyperparameter tuning. So let us execute this training model. So it is running. You need to wait and see the result. So now your model has been trained. As these are the true value, these are the predicted value. So you can see the accuracy of the model is 97%. And on training data set it is 97%, and on testing data set you can see the mean squared error here. It is less than 2%. It is around 2%. It is 2%, more than 2%. And here you can see the on testing data, the accuracy, the mean squared error is 0.186, and mean absolute error is 0.278. R square value is 0.81, and for training data R squared value is 0.97. You can also go for hyperparameter tuning. Let us select a different model. Let us select gradient boosting model and do hyperparameter tuning. So let us execute. Hyperparameter tuning generally take larger time to execute. So it is searching the best model through grid search method, and then it will apply. So let us wait for hyperparameter tuning. So now these are the model after hyperparameter tuning. So for decision tree model we have R squared value 0.86, and For testing data set, R-squared value is 0.81, mean squared error is given. So these are the best parameter fitted for decision tree model. So these are the value. Learning rate is 0.1%, learning rate is 0.1, maximum depth is 5. So these are the best fitted model after hyperparameter tuning. So you can go either without hyperparameter tuning or with hyperparameter tuning. So this is what your model is. Now you can save this model. So save this model. So your model has been saved to trained gradient boost model.pkl. Now you can use a job lift function, or you can predict new data set with this. So here you can go with, you can select this value and you can enter the data file name and you can make prediction. So this is all about end-to-end machine learning project on pyMarketLab. So we have made a regression model, we have built a regression model for predicting price of the houses. So this is a very easy software for domain expert, for those who don't want to be entangled with numerous libraries of Python. This software simplifies your machine learning process. Also it reduces your workload for machine learning tasks. You can select various models, various parameters and do the machine learning project. So thank you very much for joining this session. Have a nice day.